Hello everyone, welcome. My name is Eduardo. I'm the incubation engineer for MLOps here at GitLab, and today I'm going to show a demo of the current functionality of the model registry, but I'm not just going to show it as the website itself or the features, but a new workflow for data scientists, an idea of how to use merge requests for managing the state of their models. So, just to kickstart, what is the vision? Where do we want to get with this whole thing that we are working on? My main goal is to make GitLab a tool that allow or help data scientists to manage their own machine learning models. From creation of the model until the deployment, until monitoring. So instead of the data scientist going and creating a model and shipping the code to a DevOps team for them to manage, I would like for the data scientists to be able to use GitLab to help with that whole process. So the data scientists can create their machine learning model with GitLab, store the code, store the model artifacts, create a pipeline for this, and ship the model to production, all managed through GitLab. And the model registry is a huge step towards that. It allows data scientists to store the packages of their created models combined with the pipeline. This makes for a very powerful tool, as we're going to show soon. So a quick disclaimer. This will show both model experiments and model registry, which are both features developed within incubation engineering, and they are currently at the experimental level. So we might see some API changes or front-end UI changes in the future. But at 16.2, model experiments was made available, and at 16.8, model registry is already available to all users. So just to set up the scene of this demo, I am a data scientist and I just finished creating my model. So I created a model in a Jupyter notebook and I want to package it and to send to a team that will put this into production. But I don't want to send the code itself, I want to send a package to them. I want to run hyperparameter optimization to see which one is the best package or which one is the best configuration for the model, and somehow analyze all of the possible candidates that are created within this, or trials or candidates within this study, the optimization, and then choose one to become a model version. And okay, let's go through the demo. So how are we going to go through that? I was thinking how to really capture this process of, okay, I'm trying out a bunch of different modules and then choosing one. And this seems a lot related to how branches work with Git, and you have the main one. So what I did is, for the hyperparameter tuning, I'm going to create a merge request that is going to trigger a pipeline, and is going to train all of these trials. And then I'm going to choose one. I'm going to merge this code. I'm going to choose one to become a model version. So let's see how this works. This is a project based on top of the work by my colleague William Arias. And it sets up the CI for what we're talking about. So I'm going to go into my code base, and I have two notebooks over here. One is the one that trains candidates. Candidates are trials or a combination of parameters of data and a model and a code. So I'm using here the breast cancer dataset from Scikit as an example. And what it does, it splits the data and uses Optuna. Where can I see? Here. This is the wrong. Okay, this one. This trains and then uses Optuna, which is a library, open source library to train to do hyperparameter optimization, and uses the integration of Optuna and MLflow. What it does is it's going to create a bunch of different trials and choose the best one, allows us to choose the best one. And what I've set up is I'm going to use GitLab Model experiments to track all of these different candidates and see which one is best. So to connect with GitLab Model experiments, which is under Analyze Model Experiments, I have 2 experiments already. I'm going to use the breast cancer experiment. So I already created a bunch of different on the past, a bunch of different candidates already, and you can see that you can track many values. So over here, this is the code that is necessary to track all of that. And let's see how it goes. Let's say that I want to create a change, and I'm going to do depth-wise. Instead of, let me just see if this is the correct implementation. It's xgboost, grow policy, parameters, grow policy, depth-wise, exactly. So this would be the default, depth-wise. And this is a small change that I made that I will create a branch, git checkout, -b, use depth-wise, grow policy, for which I will git checkout -b, use grow policy. I'm gonna push. Oh, I didn't commit, right? Git commit -m, git commit -m, use grow policy, depth-wise. And then I'm gonna push. And on GitLab now I can click over here to create a merge request. Use grow policy. I'm just gonna change the project quickly. Okay, use depth-wise grow policy. I can add a description or anything, and then I can create the merge request. The first thing that we can notice is the changes. I changed a notebook, but look at how nice it displays the change. You are reading this change as it was code itself. This is part of our effort as well of making Jupyter Notebook Divs much more readable within GitLab. But here I could comment, I could ask my colleague to review the code, but that's not what I want to show right now, it's this. So I'm going to explain this soon, but what I did was when I created this merge request, I configured a pipeline that will train the candidates and will post the metrics over here. So let's start this candidate. This is a manual pipeline. I don't want to be training models on every single MR that I create, or every single commit. So let's kickstart this pipeline, and I can see it starting already. And while it's running, let's go back to the code base so that we can walk through. So this uses, as I mentioned, this is Optuna. It creates an experiment with and tries and uses the MLflow callback to track within GitLab. And how do I set it up? How do I set MLflow to call GitLab instead of an MLflow instance in itself? This is done through CI variables, 2 of them that I have. CI/CD, I can show over here. Variables, expand. These 2 variables over here are what are necessary to configure MLflow. So the first one is the tracking token, which is your personal access token. If you set with this name, MLflow will pick up for authentication. And the second one is MLflow tracking URI, which is the path. In this case, I'm setting to this project over here. And if you want to get this value, this path, you can come to deploy model registry, and you can copy the MLflow tracking URL from this path. So it's still running. So this is how you set up. This will log the CI job to the MLflow to the candidate as well. So MLflow uses runs. We call runs candidates. It will log all of the params. It will log also the artifact, and then it will create a new model with the best parameters and compute some metrics over here and create a report of those metrics and post as a comment, right? So let me show how the CI looks like for this. This is the train candidate job. What it does is on a merge request, it creates a manual trigger that will install the requirements and use Papermill, an open source library to execute Jupyter notebooks to train these candidates. And then it will call this publish metrics comment, which uses GitLab, our CLI, or our tool to manage, to create the comment over there. So let's go back and see if it has finished. Yep, it has finished. Job succeeded. This is the first step of training. And if I go back to model experiments over here, this was created 53 minutes ago, but if I refresh over here, I see a bunch of new candidates, fresh new candidates that were created. And I can see that before the growth policy was lost guide, and now it's depth-wise. It logs all of the parameters that were used during the training, and most importantly, also stores the cross-validation score. So now I want to find the highest cross-validation score to become my next version. So here I have the next version, right? So let's look for cross-validation score. And it seems that this one with minus 0.01 is our best one that was created before, but let's choose this one to be our new one. So let's see what it looks like. So I can see, for example, that the ID of the MLflow, no, let's choose another one. Let's choose one from this MR just for the sake of the demo. So let's see that this one was, let's say that this one was the best. So it logs, it logs which one was the pipeline that created this candidate. So I can see all of the logs right away for the creation. I can see who created this candidate, what merge request, all of the parameters. A lot of metadata was automatically recorded, and I can see also the model performance, right? So if I go back to my merge request, which is over here, I can see that it also properly created a metric report for the best model. So let's see. Let's say that I'm fine with this code, and now I want to create this a version so that an application can consume this. How would I go about that? If I look back to the candidate, it can also log artifacts. In this case, I only log the requirements, but I'm gonna show how I can create this model. So let's say that this is fine. I'm gonna merge this code. I like the new version. So let's merge this. And now what's gonna happen is I need to instruct that I wanna create a new version on top of that code. So this was merged. And what I'm gonna do, I'm gonna go into model registry. And I see that I already have a model with a bunch of versions. So this is the breast cancer predictor with a bunch of versions, and I want to create a new version. So the last one is 8.0.0. Let's create 8.0.1. So I'm going to go now into master, because I already merged the code, git checkout master, and main, sorry. And similar to how you release software, we can use tags for this. So I'm going to tag this commit that was generated with the version 8.1.0. And this is where the interesting part. So I created the candidate, right, with that the best candidate was trained with a specific set of parameters and with a data set. Now suppose that I was working and in my company there's a separation between production data and synthetic data, and I'm working with the synthetic data. I don't want to I don't want that model that I created to be the model that goes into deployment. I want the pipeline to pick up new data, production data, and create a new model. So what I'm going to do is I'm going to pass on all of the parameters of that candidate that was trained to instruct the pipeline to use those with a new data set. So let's say which one was my best. I'm going to pass the ID. So I have this one. This one is going to be the ID that I'm going to pass. And then I'm going to push my tags. I'm going to explain how I set this up in a few minutes, but let's just go through the process first. And this created a tag, and if I come into build pipelines now, I can see that a new pipeline was created for this tag that I created, 8.1.0, right? I created a manual, again, pipeline for this because I don't always want to train. So I want this to be more intentional. So I'm going to train. This is not a model candidate anymore. This is now training a model version. And I'm going to create this, and I'm going to open just to see what's going on. So while it's training, let's go through the code quickly. So training model version does a very similar thing as model experiments, as training a candidate, but now it's going to pass a model version, which I want to train, uses paper mill, and also going to pass a source candidate ID. So which candidate to use the parameters from. And this is also a notebook. So in the first cell, we use a paper mill. Paper mill will replace these variables with the correct ones that I'm passing. It's going to fetch some configuration, split the data again, and this is where it's interesting. I use MLflow client to fetch that candidate that I had before, that I had trained before, and then I pick up all of the parameters of that source candidate and create a new model with those parameters. And then I can pass any data that I want. In this case, for example, is the same, it doesn't change, but it passes any other set of data that I want. I might not have seen the data before even. I might not even have access to the data. Suppose it's red data that I don't have access to, only it's under a very regulated part of the code of the infrastructure, so I don't have access to. It's going to train one, and it's going to create a model so that we can create the metrics for this model. What it's also going to do now that I created a smaller model, it's going to create a larger model. So when we are training, we often split data 70-30 or some split of test and and train, but it's often preferential for the model that goes into production to be tested on the whole data, to be trained on the whole data. So it trains a new model, a final model with this whole data, and creates and saves the file as a job, as an archive, a binary. And then it uses MLflow, again client, to create a model version, and by passing this tag, MLflow in itself does not support versions in like named versions. 8.0, it's just numerical. So GitLab, you can pass a version by using the tags. And when you create a model version, it will create a candidate for the model version so that you can log all of the parameters, log all of the metrics that you want, and we're also going to log that report that we saw before into the model itself. And it's going to log the model and all the requirements. So if I go back to the model registry, so I see that the pipeline was successful. And if I refresh, I can see my new version, 8.1.0. This is the latest version. So I see all of the past versions, and I see that it saved my file over here, my model, with the requirements and also the metrics report. So if I want to share this, for example, later with for regulatory some audit or anything related, I can save files to give more context on the changes, images, reports over that model directly on GitLab itself. It saves all of the parameters. I could have saved as well the CI build over here, but it didn't pass the correct parameter. But this could have been added as well so that you know all of the logs of training that specific model, all of the parameters. So if you want to train a similar model or the same model in 2 years, you can still see all of the data over here and all of the performance of the model. In this case, I only have one step, so there's no curve, but I could see more steps during the training. So if I'm training a neural network, I can see per epoch and so on and so forth. So that concludes the demo. With this, I can send now this link. I can open the latest version and send this to my colleagues on the DevOps side or on the deployment side, and they know how to proceed. I could also have passed a better description about this model version, but that comes with another demo. So yeah, this was the what I wanted to show. So, but there could have been more that could have been done. So first of all, I could have used remote development. Remote development is GitLab's way of creating a development environment directly on your browser. So a remote development environment. So you could have your organization configure your data access without you having to worry about. So the environment that you get access to already has all of the data provisioned, all of the access requests, all of the libraries that you need, so no setup time. Another thing that I could have done, for example, is add review apps. So review apps is a feature that you can add in the merge request, a small web app or something that you can test those changes. So I could have added a web app where you can load one of the candidates and test the model with new values. Another very interesting thing that I could have used to improve this even more is use the CI components, which is a new feature that was recently released on GitLab to make CI components reusable, CI instructions reusable. So I could have, for example, instead of adding my own step or working through my own step of publishing a note to the MR, that could have been a CI step that I could have reused and add to all of my MRs that I want to work on. So just to see how the potential of GitLab being part of the data scientist workflow, GitLab enabling this sort of workflow. Of course, what I showed here is not the truth or the only way to do this. This was one way of deploying of packaging a machine learning model, one possible process. The correct process is the one that better suits the company, the organization structure. That was just one example. And what's next for model registry? What we want to do now, we have this enabled, we have released model registry, And now we are consolidating this. So model registry is an experimental level. We want to push this to the beta level. And to do that, there are a few features that we want to go for. So one is support for storing your models in your own cloud, because we know that models are usually classified as data and need to be geolocated often. So data that it's Europe, the model should be in Europe or the US, depending on the legislation. And we want to allow, we want to enable data scientists or the infrastructure to store on your own, on the better place for you. General UI improvements. We also want to provide a better user experience when promoting a model, a candidate to a model. So for now, I used for the Git tag, but we want to allow data scientists to be able to do this through the UI itself. So no, not through Git, but through the UI. And better markdown description for both model and model version. So think model cards, or that report that I showed could be the description of the model version in itself. So these are our priorities for the next months. And that's what I had. Thank you for watching. If you have feedback and on this, on testing or ideas or feature requests, please reach out on the Model Registry Epic. If you want to follow up what we have been working on, follow us on the MLOps YouTube playlist here at GitLab. Thank you very much. Bye-bye.